So what is a geometric sequence? What do we even mean when we speak of a geometric sequence? Well, I'm not going to get into the details about what it is. You don't really care. We don't need to know. But it just means a sequence where the things are multiplied. Geometric sequence means multiply by the same number called the common ratio right here. Common ratio. Each from term to term. From one term to the next. From one term to the next. Okay. So in other words, and I should say G0 is the first term. So they're giving me G0 right here. They're saying G0 is 7. That's the starting term. The sub-zero, that little sub-zero, that's just like a counter. That's the start. They're saying G sub 0 is 7. The first term is 7. Okay, then G sub 1 is the next one. Then G sub 2. Then G sub 3, etc. Is that making sense? So far, so good? So G0 is just the name we give to the first one. And then G1, G2, G3, etc. from there. Okay, so now what are you going to multiply by every time? 1.25. That's what that common ratio is. It's the number you multiply by every time. So then that means you just take the 7, the first term, and to get the next term, you go times 1.25. Just grab your calculator. Go 7 times 1.25. And I'm getting 8.75. Did you guys getting that? And then how do you find the next term? Same thing again. Just do it again. Just go times 1.25. Just use your calculator. Go times 1.25. I'm getting 10.9375. I don't have room for that. I'm going to have to squeeze it over here. 10.9375. So times 1. What was the question?
Where did you get
10 from? I don't see 10 anywhere. Oh, so I'm just taking this number and multiplying by 1.25.
Oh.
So every time I'm just multiplying by 1.25. Just times 1.25, times 1.25, times 1.25. That's all it means to be a geometric sequence. You just multiply by the same number every time. Just fancy talk for multiply by the same number every time. And just keep going. Now, how far do we got to go? They want me to go all the way to G5. So just keep going. A couple more steps. So do it again. Use your calculator. Times 1.25. Oh, you get some crazy long number. I'm getting tired of it at this point. Can we save some time by observing a pattern? Math, science, it's all just patterns. So here I'll write, what is this one? 13. 13.671875. Right, getting that one? So is there a nice quick way we could just jump all the way to G5? I mean, it's 2 steps, but I'd rather not. What's a quick way of doing this? Do you see the pattern? Let me go to a fresh screen. Let me help you. So G07, that's the first term. Okay? And then G1, you just go times 1.25, and I don't remember what it was, 8.75. And then G2, G3, what was it? 10.9375. And this one was 13.671875. So times 1.25 times 1.25 times 1.25, etc., right? So now let's try to do a quick way to do this, where we can just skip right to it. Like if I wanted to find G10, for example, without going through all the steps, is there a quick way? So we're doing math and science now. We're looking for a pattern. That's the essence and the power behind everything we've seen science has done for us. It's patterns. So what's the pattern? Tala.
Well, I kind of experimented a little bit.
Okay, good.
What I did was, sorry.
No, you're good.
I typed in.
Yeah, let's just go down. So G4. I'll jump down to G5 like you are. So you're saying you took 1.25 to the fifth power and multiplied by 7. And you are right. How'd you come up with that?
I just thought, since 1.5 is multiplied in each one of them, I just, jumped into it.
Yeah. Beautiful. Does everybody see what Tala's seeing there?
Yeah.
So in other words, like look at the third term, for example. How do we get this number, the third term? Well, we started with 7, and we multiplied by 1.25 3 times to get to G3. Right? In other words, G3 equals 7 times 1.25 to the third power, doesn't it? Does everybody see that? The way we get G3, what did we do? We started with 7 and we go times 1.25, times 1.25, times 1.25. Right? 3 times. Once, twice, 3 times to get to G3. We start with 7, right? We started all this with the number 7. And then you just go times 1.25, times 1.25, times 1.25. To get to G3, you had to multiply 1.25 3 times. I could write it sideways first. 1.25, 1.25. But the shortcut for that is 1.25 to the third. That means the same thing. We all good there? Just multiply by 1.25 3 times. So to get to G3, you multiply 1.25 3 times. So to get to G10, how would we get G10? Dot, 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 all the way down to G10. What's the formula going to be? 7 times to the 10th, You see, whatever number's here, just do the same thing there. And you can save time. Somebody got G5. They want G5 from us. What's G5 on the calculator?
21.3623.
Oh, it's a bunch of... do they want us to round or something? Oh, 3 decimal places. Yeah, I should have been rounding to... Or I guess I did for the first one. They want 3 decimal places. Yeah. So it comes out, 21.362. Round to 3 decimal places. They don't want G10. I was just doing that for fun. You know what they really want? They want Gn. So if you put an n here, which means that could be any number, where am I going to put the n on the right side?
At the power.
Beautiful. Yes. Everybody see that? That's the pattern, Whatever number you have down here, right? Whatever number you have down here, that ends up in the power. Doesn't it? Everybody see that? Whatever number you have down here ends up in the power. See how this just goes to there? So if that's in, same thing, You just have a 7, a 1.25, and boom. See how we just got that by looking at the pattern? The power of patterns. That's what's going on with all of science and math. It's patterns. There it is. That's all they want from us. So that's the answer to Gn. This is exactly what they want you to type in for Gn. We got that. Let's go then to number 2, if you're good. Okay, so crime in Happyville is on the rise. Each year, the number of crimes committed increases by 50%. Assume that there were 216 crimes committed in 2000, and let Gn denote the number of crimes committed in the year 2000 plus n. How many crimes were committed in 2005? That's fancy talk there. Here, let me just make it simpler. So number 2. So what does it said? There was 216 in the year 2000. So in the year 2000, there were 216 crimes. Okay. In 2001, what does it say it does? It increases 50%. Increases 50%. it's going to increase 50%. So we learned yesterday how to do percent increase and decrease. It's on the sideboard still. Remember the formula? Percent increase, you take the new, it'll equal the old one times 1 plus, or well, I should have put it's 1 plus the percentage comes first. Doesn't really matter what order. 1 plus the percentage times old. The new equals 1 plus the percentage times old. Remember that? You just stick a 1 in front. We talked about that. So therefore, if you want to increase something 50%, first we're going to plug that in. So the new amount of crime, like the amount of crime in the year 2001, will be 1 plus. Now, what do I do with that 50%?
Decimal.
Yeah, we always make them decimals. When we stick them in formulas, we always change percentages to decimals. So make it 0.50 times the old. What's the old amount of crime? 216. So the new will be 1.50 times 216. Hit the buttons on your calculator. 324, I think, right? 324 crimes in the next year. So remember that? Remember the percent increase, decrease formula we did yesterday from the last section? Anytime you want to do that, it's just 1 plus the percentage times the old. Question, Anna? No, they didn't really ask me how many crimes in 2001. I was just getting us rolling. What they're asking me for is how many, they said 2005. So how many crimes in 2005? Well, we want to, the power here, patterns. Look for the pattern, right? So let's go back. How could we jump down to 2005? So every year it's going to go up. It's going to increase 50%, which means you're going to go multiply by 1.50. See how it's just like the last one, really? You're going to multiply by 1.5 because that's 1 plus 50%. Right? Isn't that what we just did here? How did 216 become 324? I multiplied by 1.50. When you increase something 50%, you multiply by 1 plus 50%, 1 plus 0.50, 1.50. So you multiply by 1.50. So how would you get the crime in 2002? You would multiply by 1.50 again, etc. Here, let's do a little.
I see it.
Let's do a little bit more. That would be more helpful. Yeah, some of you are seeing it. Let me do a little bit more. So 2002. Here, let me write it a little more clearly. You have to write it clearly to be able to see the pattern. So you start with 216 because that was the, just like 7 was the starting number on the last problem. 216 is the starting number here, and go times 1.50 times 1, whatever that number would be, I have no idea or care, and times 1.50, etc. You just keep multiplying by 1.50 because that increases 50%, doesn't it? 1 plus 50% on that.
It's asking us what the crime would be in 2005?
So they want us to go all the way down to 2005. So, for example, how would you get 2003? Let's see if we've got the pattern. 2003, you got to start with the 216. That's the start of it all. And multiply by 1.5, 1.5, 1.5. In other words, 1.50 3 times. Right? Is that making sense? You got to start with 216 because that's the start of it all. And multiply by 1.50 3 times because that's, right? Because once, twice, 3 times. So if you want to get down to 2005, what's the formula going to be? 216. 1.50 to the 5th. See, this number matches that number, doesn't it?
Oh, yeah.
See that? Making sense? So let me get that in a calculator. So 216 times 1.5 to the 5th. I'm getting
So basically,
1640.25. There was 0.25 of a crime. They like started to do the crime, but they stopped. That room, go back and look. Is that what they want? Just round it. Round it. So just round it. All right, so just get rid of that 0.25. 1640. So 1640. All right, now they want the general formula G sub n. G sub n. So, oh wait, yeah, I'm doing the right one. G, yeah. So same kind of thing. Basically, now what's n? It's just going to be like 2,000, plus n years. It's the same thing. It's just n years later. So what's it going to be? 216, 1.50 to the n, right? Because this matches that, just like 5 matches 5.
they're asking for the formula?
Yep.
Okay.
On the next part. That makes sense? Just the same pattern.
What was
Just however. What's that?
What was the question?
It was find this formula. Find the 2,000 plus n years. So n years, bless you, n years after 2,000 is going to be, just pop the n right there. See the pattern? Whatever the number is after 2,000, put it on the 1.50. Because just multiply by 1.50 every time to increase, 50% every time. So that would be this answer here. What was it? I already forgot. 216. So it's 216, 1.50 to the n. All right. And then part C, if the trend continues, how many in 2010?
So we just plug in 10 years.
Exactly. So for 2010, it's going to be 216, 216 times 1.50 to the 10th. Right? Hit the buttons on your calculator. 12. Wow, it's a lot of crime. Happyville is not so happy.
That's if it increases every year by 50%, right?
Yep.
So if it was different, like say this year it increased 50%, the next year it increased 30%.
Then we'd have to do something different. Yeah, this is steady, same increase.
Okay.
Yeah, you're right, Jessica. That's exactly it. So mine came out 1245.6, if you can read that. 1245.6, and I guess we'll round that up. They said round to the nearest. So 1245.6, if you can see that there. So I'm going to round that to 12,456. So this would be 12,456. Is that good? That makes sense? So I just did this formula on my calculator. For 2010, it's 216, 1.50 to the 10th. Right? Whatever the year is, you just do that as the power. Don't you? And then use your calculator. I can move it up here a little bit. Get this out of the way. It came out to be 12,455.6. And so 0.6, we round that up. So 12,456. Think about what's happened in Happyville. 216 crimes in 2000 goes up 50% every year. 10 years later, 12,456 crimes.
We need Batman.
Yeah, that's right. It's Gotham. Yeah. So it's going up like crazy. Notice the power. This is why, now we're going to do this with money in a little bit. This is why Einstein called compound interest the seventh wonder of the world. See what he was meaning? It's explosive growth, isn't it? And that can happen to your retirement savings if you put it away regularly explosively. So, all right, so 12,456. So, all right, let's go down to number 3 then, for purposes of money. All right, so starting at age 40, Marcus invests $2,500 at the end of each year in an IRA, individual retirement account, with an APR of 8.5% compounded annually. How much money is in Marcus's retirement account when he retires at the age of 65? Assume that his 25th and last deposit generates no interest. You don't need to do anything with that. So he's going to put $2,500 at the end of each year, which is about $200 a month, right? So he's putting away about 200, right? 200 times 12 would be 2,400. It's close. So he's putting just over 200 a month. You probably pay that for your cell phone and your TV rights, right? 200 a month. He's going to put away. What's he going to have? So I'll just make. You don't need to write all those crazy words. Let me just make it simple. He's putting 2,500 per year. Here's all we need. 2,500 per year. He starts at age 40 and he goes till 65. So how many years is that? 25 years. So I'll just write 25 years. That's all we care about. He does it for 25 years. From age 40 to age 65. So he puts away 2,500 per year for 25 years. What's the interest rate he gets? I didn't see that. Oh, there it is. 8.5% compounded annually. At 8.5% compounded annually. I believe that's all we need. Yeah, we don't care about the rest. So that's in his IRA, his independent retirement account. All right, so let me basically say that again. So when you save for retirement, basically that is a little pile and it grows. You're putting more and more away into the bank, ... and it's a big pile in the future. You're saving for a big pile in the future, or just saving to buy a car, go on vacation, or whatever. Any kind of saving for the future. So that's called future value. Future value. And it's a series of payments. It's a series of payments, which is called an annuity. It's annuity, series of payments. Future value formula, it's P bracket. A math Excel does a different formula here. Theirs looks easier, but they're hiding the hard stuff. Just do this one. This will work better. They have I, and I can be weird different things, and that's confusing. So P is the payment that you make every time. All right, there we go. So there's the future value formula. Let's use it. Getting back to it. So future value. Marcus wants to know, what's he going to have in 25 years? It's going to be P bracket, what is it? 1 plus R over N to the NT. It's kind of like the compound one, huh? It's got some similar parts. All right, let's plug everything in. So the future value, I'm going to move over here to have room. What's the P?
2,500.
Yeah, that's the 2,500, the amount he's putting away every year. 1 plus, now what's the interest rate?
0.08.
Yeah, move it 2 places back, boom, boom, like yesterday, 0.085 over N. What's N? Annually? N is just 1. And remember, N ends up here also. Time? 25 years, right? Minus 1 all over. And this is the same. These two guys will always be the same. See how they're the same in the formula? See how it's always R over N, R over N. It's going to be in the other formula too. Same thing. Julie.
How do you get 1 with 25 years?
So it's N and T. N is 1. T is 25.
How do you know N is 1?
Annually. Annually means once you have a birthday annually, once a year.
So it would be like monthly, that'd be 12.
12, and it'll often be monthly.
Okay.
Yeah, it'll be pretty much be monthly. It'll almost always be monthly, and it'll be 12. Monthly or annually, yeah. Yeah, that's right. So there it is. Now, we need to crank that out. That's easier said than done. Let me rewrite it on a fresh screen where I can write for you the steps. Yeah, so it's going to be 2,500. What's it again? It's 1 plus 0.085 over 1 to the NT times 1. 25 minus 1. Okay, so first off, let's get rid of those ones. Like this one is doing nothing. Dividing by 1, that's not doing anything, huh? So let's just get rid of that. So this becomes 2,500 times 1.085 to the 25th power minus 1 over 0.085. Good there? Here, I'll put it back the way it was. Yeah, good enough. It's same thing either way. Is that good there? Yeah, dividing by 1, that does nothing. So I just got rid of this dividing by 1, dividing by 1, basically. Dividing by 1 doesn't do anything, right? All right, so let's do this on our calculator now. Now, there's all kinds of ways. I don't care how you do it, but this will be the easiest way. From the end, because you don't want to get caught up in all the parentheses bracket stuff. It just gets confusing. Start on the inside. So first I would start, this is the innermost area, basically, right? That's the innermost area. Start right there. And get in the habit of hitting equals after every step. So I'm going to go on the calculator, 1 plus 0.085, hit equals. Then go to the power. That's on most of your calculators, that's y to the x. Some of them it's the up arrow. To the power 25 equals. Everybody said, then I've done this whole thing here, right? You tracking with me so far? So I'm just literally typing this in. 1 plus 0.085. But you got to hit equals after every operation. If you miss the equals, it'll do something different that you don't want. So 1 plus 0.085 equals. To the power 25 equals. See, every time I just keep hitting equals. Minus 1 equals. Now, how am I going to get this into the picture? Divide. Divide by 0.085 equals. And then beautiful. That 2,500 in the front. Exactly. Times 2,500 equals. Never had to worry about parentheses or anything. Just go inside out like that. And I'll do it too. 196,669.48. What is that? 190,000. Look at that.
Wow.
Almost $200,000 saved up. He just put away $2,500 every year for 20 years. So how much money did he actually take out of his account? Do you realize that if he put $2,500 every year for 10 years, what would that be? For 10 years, just multiply by 10, 25,000. And then 20 years, double that, 50,000. Then he did another 5. He did like 60,000. Yeah, about 60,000. What is it? So actually 62,000 whatever came out of his account, yet it stored up to almost 200,000. He got a free $130,000. See the power of interest over time. See why Einstein called it the seventh wonder of the world. Right? And this guy didn't start till he was 40. Start when you're 30, and the power is amazing. I should have. No, so number 4, suppose that you save $10 a month. Put the money at the end of each month in an IRA, APR 7.5%, compounded monthly. How much money will there be in your retirement account in 35 years? $10 a month. That's not very much. All right, so let me write out the details. So $10 per month. And what else did it say? 7.5%, yeah. At 7.5% compounded monthly, I think it said. Compounded monthly. Compounded monthly. How much in 35 years? 35 years later. All right. So we're going to need to do the future. Okay, so it's going to be, formula is P1 plus R over N to the NT minus 1 over R over N. So it's going to be P. That's just the 10, right? The P is just 10, the payment, $10. And 1 plus R over N. This is the interest rate. Move the decimal back 2 places. 0.075 over N. N is 12, isn't it? Monthly. N is 12. So this is 12 times 35. Yeah, minus 1 all over 0.075 over 12. So a little messier with the 12 in there. Okay. So here's what I would do. So there's certain, I'm going to try to suggest to you the way that'll be quickest and most painless. So there's certain things I would figure out and certain things I wouldn't mess with that you don't want long decimals. Here's what I would do. Figure this out right away. That's just a clean whole number. Just take your calculator all by itself, just 12 times 35. What is that? 425. So just 420, thank you. 420. So just figure that one out ahead of time. The rest of the stuff, you're just going to leave it. Okay, so here we go. So where am I going to start? Start on the inside, which means I'm starting right here, right? On the innermost area. So 1 plus 0.075 divided by 12 equals. So see how I do that? Inner parenthesis equals. I always do a section equals. Section equals. So I did 1 plus 0.075 over divided by 12 equals. Good so far? To the power 420. So that's why I figured that out ahead of time. Because I didn't want to mess with a couple things up there. Just want that power clean. To the power 420.
-1.
Right. So hit the Y to the X, which is the power button on most of your calculators. Somebody might have an up arrow. To the power 420. Don't forget to hit equals. Equals. -1 equals. Got the whole numerator now. We good so far? Because I got to show you a trick now for that denominator. Is everybody with me to that point? We've got this entire numerator put in right now, don't we? So now all we got left to do is to divide by that fraction on the bottom and multiply by that 10 that's in the front. But the trick is, how do you divide by an entire fraction?
You have to reduce it.
There's lots of things you could do. That would be one of them. To make it as painless as possible. If you divide by a number that's divided. Yeah, exactly. That's right. You know that. All right. It's reciprocal. That's right. There you go, man. It's the language. Yeah. Do you realize that? Let me help. If you what's the quickest way to say this? Let me say it in two ways. You're basically going to divide by this number, and you're going to multiply by that number. Because that 12 is divided. Right? It's underneath, and it's underneath, which means it's actually multiplied. Does that seem bizarre? Let me say this. What if I said, hey, I brought 10 candy bars to class, okay, and I'm going to pass them out, and I'm just going to pick. I'm going to give them out 2 at a time. I'm going to divide them into 2 candy bars. I'm going to give people 2 candy bars, 2 candy bars, 2 candy bars. How many people are going to get candy bars? Right? 10 bars, 2 bars per person. There's only going to get 5 people who get bars. The whole class is not going to get candy bars. I won't have one for everybody. Right? But if instead I take those 10 candy bars and I divide it 1 per person, 10 people will get candy bars. That's still not the whole class. But what if instead I do what with those candy bars? You know where I'm going? Cut them in half. I break those candy bars in half, give everybody a half a candy bar. Will there be more people or less people getting candy bar now? More, right? It's going to be 20 people, right? Because there's 20 halves in 10 whole candy bars, aren't there? Do you see my point? Divide. What did that 2 that's... See, this is the same. This right here really is 10 over a half, isn't it? It's 10 divided by a half. And what does that 2 end up doing with the 10? It multiplies. It's real life. Right? When you divide by a fraction, it actually multiplies. Right? Take the 10 candy bars and break them into halves. That gives you more. Right? So dividing by a fraction actually multiplies. That's what Jared meant with the reciprocal. That's exactly right. Basically, that thing on the bottom flips upside down. Doesn't he? Remember that old rule? I don't know if you remember that old rule. If you take 10 divided by a half, you change to multiply. Some people call it keep, change, flip. Keep, change, flip. Right? You change this to times and you flip this guy. Because, whichever way you want to say it, because dividing is upside down multiplying. How about that? Dividing is upside down multiplying. That's all it is. So if you divide by a half, you're really multiplying by 2 over 1. That's why you get twice as many people that can have candy bar. All right. So that's the reason. That thing on the bottom, you just go divide by the 0.075. This will be the most painless way. Divide by the 0.075. And then multiply by the 12. And then you also got to multiply by the 10 that's in the front. Don't even need to hit equals till the end. You can hit equals in between if you want. Doesn't matter either way. And that'll do it. So do you see what you do? We're going to have a bunch of these. Do you see what you do again with the fraction down below? Just flip it upside down. So you multiply by the 12. You divide by the 0.075.
Can we hit equals after we divide it?
You can, or can just wait till the end. It'll work either way.
Okay. Interesting.
Does that make sense, Tala?
Why you get 10?
What's that?
Can you explain again why you get 10?
Probably the best way I could do it is, would it help if you just grab this fraction here? Let's do this. Probably the cleanest way. Just grab this fraction and just do reciprocal. I just like Jared's phrase. That's a good one. Just take 12 over 0.075. It really just flips because dividing is upside down multiplying. So if you divide by that fraction, just flip it. And so that shows that the 10 and the 12 are in the top, so they're both multiplied. And the 0.075 is in the bottom, so it's divided. See why it's divided? Any order on that, by the way. You can shuffle these 3 in any order. Doesn't matter which order you multiply, divide. Shuffle them around in any order. It's all good. Doesn't matter. Hit equals in between or wait to the end. It's all good. None of that matters. It'll all work out. Just as long as you remember that it is reciprocal. Dividing by a fraction actually flips it.
That's like figure it out.
Yeah, so just flip it. Multiply by the 12. Divide by the 0.075. And you should get a number. So it equals 20307.62. $20,000. Just $10 a month. Does that make sense? Y'all able to get that in your calculator?
Yes.
Using those steps?